Top 9 Turning Operations Explained Simply. Ever watched a metal bar spin rapidly on a lathe and wondered what's actually happening? It's a precise process called turning. Turning operations are the core of most cylindrical machining tasks, from making bolts and shafts to crafting aerospace parts. In this video, we'll break down 9 key turning operations you can perform on a lathe, explain how each one works, and why they matter. So what exactly is turning? In simple terms, turning is a machining process where a cutting tool removes material from the outside surface of a rotating workpiece. Unlike boring, which enlarges holes from the inside, turning shapes the external diameter to the desired size and form. What makes turning so common is its versatility. It is fast, it is accurate, and it can achieve smooth, round finishes with consistent diameters. Whether it's a small pin or a massive roller shaft, the lathe can handle it all. Within turning itself, there are several specific techniques, like step turning, taper turning, chamfering, and contour turning. These are all basic external turning operations. Basically, pick the technique that fits your part. Use step turning for multiple diameters, taper turning for angled surfaces, chamfering to break sharp edges, and contour turning when you need smooth curves or complex profiles. Now, move on the key turning operations that give your part special features and finish it up. Let's start with tapping. It involves using a multi-point cutting tool to cut threads inside a hole. On a lathe, the workpiece rotates slowly on a faceplate, while a fixture holds the tap on the tailstock spindle. Different tap shapes can create metric threads, imperial threads, or UNC threads, depending on what your fastener needs. Next, threading. Unlike tapping, threading cuts external threads onto the outside of a rotating workpiece. A special threading tool, shaped to match the desired thread type, progressively carves the helical grooves as the workpiece spins. This creates threads with precise depth, pitch, and angle. Threading is essential for making threaded rods, bolts, fasteners, or any component that screws into tapped holes. Third, boring. This is all about refining and enlarging an existing hole using a sharp single-point tool. It makes the hole more precise and smooth, perfect for bearings, shafts, or other tight-fit parts. You'll often see boring used in engine blocks, gear housings, and other precision components. Fourth, knurling. Instead of removing material, knurling employs a specialized tool with cylindrical wheels, knurls, containing teeth that roll against the workpiece surface to form patterns. Those crisscrossed patterns you see on tool handles or knobs, that's knurling. It's mainly done for grip, but it can also enhance aesthetics or serve as a visual identifier for parts. Fifth, drilling. It involves creating holes in a workpiece using a rotating cutting tool called a drill bit. It's used extensively for creating holes for fasteners, pins, dowels, or as a pre-machining step for processes like tapping or boring. Sixth is reaming. This process usually follows drilling or boring to refine the accuracy and surface finish of an existing hole. It uses a rotating reamer, slightly larger than the hole, which enters along the hole axis and removes just a tiny bit of material, leaving a precise, smooth hole. It is ideal for precision fits in components like engine parts or hydraulic systems. Seventh, parting, sometimes called cut-off. Imagine you've machined a section of your workpiece, and it's time to separate it from the rest of the bar. That's where parting comes in. A narrow, flat tool cuts straight into the rotating material until it slices through. It is essential for high-volume production runs where multiple identical parts are created from a single material bar. Eighth, facing. It is usually the first operation on a lathe when starting with a raw workpiece, as it machines the end of the workpiece parallel to its rotation axis. It removes a thin layer of material to create a flat, accurately sized surface for subsequent machining. Keep in mind that facing can't create angled or curved surfaces. Ninth, we have grooving. This operation creates narrow cuts or recesses around the workpiece. There are 2 main types, face grooving and external grooving. In face grooving, the tool cuts a groove on the face of the workpiece, while external grooving removes material radially along the outer surface. Grooves can serve various purposes, to hold O-rings, create locking features, or simply improve the fit between parts. So how do you decide which turning operation to use? It all depends on what the part needs: shape, tolerance, and surface finish. For instance, if you need threads, you go with threading or tapping. If you're refining a hole, boring or reaming is your friend. Knurling enhances grip, while facing and parting are your start and finish moves. Each operation has its own purpose, but they all work together to transform a simple metal bar into a precise, functional part. And there you have it. 9 essential turning operations every machinist or engineer should know. And if you're looking to bring your designs to life, check out RapidDirect's manufacturing services. From CNC turning and milling to surface finishing and rapid prototyping, you'll get professional-grade quality, fast delivery, and expert support for any project size. If you found this video helpful, make sure to like, comment, and subscribe for more insights on machining and manufacturing processes. Thanks for watching, and see you in the next video.